Welcome to this video. In this video, we'll be looking at the targetSum algorithm, and I do hope we're able to learn one or two things from this. It's also an algorithm based off of the tree, and we are looking at the Shem-Prashad lead code series. The link is in the description. So you can go and check it there. This is the 22nd in the list, the targetSum algorithm. So let's go straight to that. So here we have the targetSum, and it says that given the root of a binary tree and an integer called targetSum, we are to return true if the tree has a root to leaf path, such that adding up all values along the path equals targetSum. And they said a leaf is a node with no children. So for example, 4 here is not a leaf because it has a child. 11 is not a leaf because it has a child, but 2 is a leaf because it has no child. Its left and right is null, so it has no child. 7 is also a leaf node, 13 is a leaf node, 1 is a leaf node. So basically we are looking for any of the path that we go to a leaf node that gives us the targetSum that we are being given. So basically that's, so for example, the target here was 22. So if we do 5 plus 4, that's 9, plus 11, that's 20 plus 2, 20. So we have a path here that conforms to that, so we return true. But here the target is 5, and if we start from 1, so there's no path because 1 to 2 is 3, 1 to 3 is 4, so there's no targetSum that gives you that. And we have an empty, and the target is 0, and since it's an empty, it can't even sum up to 0. So if it's an empty, definitely we just return false. That's what it means, since there's no node to even check it up with. Okay, and we are told that it's possible to have no item in the node, as no item in the tree, no node at all in the tree rather, and we can have up to 5,000 nodes in the tree. Also, the values for node can range from negative 1,000 to 1,000. Okay, and the targetSum can be negative up to a positive 1,000. Okay, so this is our problem, and let's go to the board and see how we'll come up with a solution for this. So basically we have, let me just have simple node here, we have another node here, so let's say 1, 2, 3, let me have 4, 5, let's say this just has 1 here. So basically let's say this is what we have 4, 5 and 6, and let's say we are looking for a path that has the sum of let's say 10. Can we find 10 here? Okay, yes. So 1, 3 and 6 gives us 10. So our target is 10, and we are told that we want to go through this tree and see if from any point from the root to any of these leaf node we have something that gives us a target of 10. So for this, because what you are going through, if you look, is either you go through this one, or you are going through this one, or you are going through this one. So obviously the obvious choice to make in terms of either it is the breadth first search or the depth first search will definitely be the depth first search, because if you look at it, you are going the depth from 1 to 4, 1 to 5, 1 3 6. You see, you are going depth. The breadth is not really of your concern in this particular algorithm. So definitely what we need to use is depth first search. But what we are doing is we want to check if when we get to a leaf node, we want to check if our target, if what we have here is our target. So the idea that's coming to my mind now is, so let's say our target is 10 here. So what we want to do is we want to go to the left and for the right. So let's start with the left. On the left, I want to tell it that I want you to check for a target. So I know that this is 1, so if I remove 1 from 10, that gives me 9. So I know what I want to do is I want to pass 9 down to 2 to this particular node, and then this node will now be asking a question that is 2 a leaf node, and 2 says I'm not a leaf node. So what I want to do is I want to take 2 from this 9 and pass it down. So that will make this to be 7 here. And then we are now asking 4. Is the item in this node, is it a leaf node? It says yes, it's a leaf node since it has no children. There is no children, so it's a leaf node. So since it's a leaf node, we now ask, is 7 equals to 4? No, so definitely this part doesn't give us a sum of 10. So we come back again, and you know, at this point where we are at 9, we will come back. Since it's def sh, we'll still come back here now from this point to this part now, because you know we have exhausted this part. So we come back to this part where we have 2 going to 5. So, and you know, at 2 what we have is 9. So we now ask 9 minus 2, that's 7. So we pass 7 down here too now, and we are asking, is 7, or rather is 5 a leaf node? Yes, 5 is a leaf node because it has no children. So is 5 equals to 7? No. So we know this is not a possible part. So we come back up here, and then we pass 9 to this because we will have done 10 minus 1 here, so we have 9. And then is 3 a leaf node? So 3 is not a leaf node, so it will also cascade it downward. So it cascades it downward, but you know what it will cascade down is going to be 9 minus 3, that is 6. So we check, is this node a leaf node? Yes, it's a leaf node because it has no children. So what we will now be asking is, since it's a leaf node, is 6 the value equals to this target which we have here, 6? And yes, it is. So we know that yes, we have a possible match here. And if at any point we have a possible match, we know that that means definitely that we have found a possible solution, basically. So that's what will be the approach we'll actually be using. So the first step is that we're checking. So you see, we'll be checking if it's a leaf node. That's the first thing. We check if it's a leaf node. If it's a leaf node, if it's a leaf node, if it's a leaf node, then what we want to do is we want to check if the target is the value we have there. But if not leaf node, then I want to I want to pass down the target to the child node. So that means, but you know, the target, I will remove the current value from it, and that's what I will pass down to the children node. And so the children node will keep checking, and then till we get to a leaf node, and the leaf node will now check if there is a target, and if it finds if it's equals to that particular target, then it's fine. If it doesn't find, then we know it doesn't have such. So basically that's the algorithm we'll be using to solve this. That's the approach we'll actually use to solve this. So let's get back to lead code and see how we can put this in code. So here, if we come here and we check our targetSum algorithm, first of all, let me just create. Now, then I think I should state this here. It's not actually compulsory for you to create a different method like I do here. It's just optional, just my preference, just the way I like to do it. Yeah, it's not compulsory to do that. So it's in some scenarios you will need to do that if the signature will change, but for this kind of one that the signature will not actually change, you could actually use the same method without creating a new one. So, but it is just my own personal preference. Maybe I will, okay, so maybe to show what I'm saying, probably I will not do this. So let's just use this particular method, since what I'm trying to return is a bool, and I think I can make use of this because even what I'm thinking of doing is going to be it has basically the same signature. So for example, and let me just Ctrl Z that back. If you look at it, the signature, it's a boolean, it takes in a root, a tree node, and it takes in an integer. So basically the same thing. So I could just do with this straight up, but let's just go with my own approach where I will just, when I'm done with this, we'll now use the method itself and try and do the recursion there. So first of all, you know, we are checking if we are at a leaf node, right? And how we know if we are a leaf node? So if the leaf node, so for example, right, if the left is null and the right is null, then I know I'm in a leaf node, and that is when I want to now go ahead to check that if the target is equals to the value there. So I want to now also, so at that point I want to check if the target sum is equals to my roots dot the value there. Then if I have that, then I know that definitely I have gotten a match. But if I don't get that, it means that, okay, so but definitely I have to check for null. So if the root is equals to null, I want to just return false. I know there's nothing. So but if if this check doesn't come out true, so for example I get a node that it's not it's probably is not at the child node, at the child node, so it will just I want it to then go in and say do the same thing as part some DFS, and I want to pass in the left. So I want it to do the same thing on the left node, but this time around what I want it to do is the target sum. I want it to take whatever is in the value here. So you remember when what we were doing here was that we are actually just cascading down. So you see from 10 we cascade down to 9 because we remove the value from our target, the value of the current node, which was 1, we remove it and pass it down to the node below it, that is the children node, the left and on the right side. So I will do that for the left, and I will do that as part some DFS and roots dot left. Okay, so this will be right, and we have target sum minus roots dot val. So basically the same thing. So I think I will just return this since both of them will be so if for any of them, but if, okay, so I think it cannot be and the reason is because I want, if I find it on anyone and it's true, then I want the whole statement to be true. So if any node is true, then I want it to return true. So basically if I use an and, it means that all node must find matches. All nodes, all paths, that leads to the leaf node must give us that particular sum. But all means if I find anyone that gives us that sum, we want to return that as true. So I think that's what I want to achieve, and I can just return as part sum DFS, and I pass in the root and the target sum. And I think so we are checking if the root node is null, we return false. If not, we check if it's a leaf node, and then if it's a leaf node, we now check if the target sum is equal to the value there, then we return true. And if not, then we go ahead and do the same thing for the left node and for the right child node. So let's run this and see. I think it looks okay. So pass that. So let's submit and see. If everything is fine, then it should be successful, and it seems yes, it is. So if we come back here, if you look, because we are returning this, that the only thing we're actually just returning, so you see it's definitely showing that and the signature is basically the same. It's just the method name that is different. So we could actually do exactly the same thing. So if I copy everything here, and put them here, okay, I need to change the method definition so that we don't think this is what is being run. Let me just comment this out. So we are basically doing the same. We are checking the roots, we are checking the left and right for child node. If it's a child node, then we now do the target, and then and then we are now checking the left node and the right node, and we keep going to the left and right downward till we get to a child node. Yep. Or till we get to the end. So let's run this also. It should be the same result we get exactly. So basically I think the point I was trying to make here is that you don't always have to go and make a different method. It's just my personal preference. There's no no need. There are scenarios where I use it this way, but I just like to make it look so that I can see that I am using the depth first search. Just something I like to do. It has nothing to do with the logic of how it runs. So once I see that once you see that basically the signature is the same, then you could actually collapse it. But if not, you could actually use it in this particular manner. Actually, I like this also because there are situations where it's actually going to be, the signatures will not really be the same because of what you are trying to achieve. Yes, so in those situations now, you will actually need to create a separate method that you will now call and do some other functions with it. Yeah, I hope this was clear. I hope we understood how we use the depth first search here to achieve our objective for this algorithm. If you have any questions or any part that wasn't clear, please drop a comment and I'll do well to respond. Please subscribe, like and share. I will see us again in the next video.